Problem 2 is a chance for you to apply the definition of either convergence or not convergence, right? Either the definition or its negation, to this sequence, the minus 1 to the n sequence, which is just the alternating sequence, minus 1 plus 1, minus 1 plus 1, minus 1 plus 1, and so forth. And walking around the room, I think that I saw most of your groups had chosen the correct statement here to prove. So did you say that this sequence converges to 0 or that it does not converge to 0? Shaking your heads. Does not converge to 0. All right, so I agree with that for sure. And so the real purpose of this exercise, since we decided that does not converge is the correct choice, what we want to do is to be able to use this negated definition to prove your assertion. So if we're going to show that this sequence does not converge to 0, so here the role of L is going to be played by 0, then what we need to show is that there exists an epsilon, a distance, for which no matter how far out in the sequence we look, we can find at least one term after that point which is further from 0 than the distance that we chose. So this is the statement that you're about to prove. And what's great about this, and the advice I was giving a few of your teams as I was walking around, is this proof begins with an existential claim. There exists an epsilon greater than 0. So what that means is that you, as the author of this proof, can be very specific in choosing an epsilon that's going to make the rest of your argument work. You can even make it a specific number if that helps. Here's our minus 1 to the n sequence in a graph, right? Negative 1, positive 1, negative 1, positive 1, negative 1, positive 1. Here on the x-axis is the value y equals 0. Right? So that's the purported limit that we're going to show is not, in fact, the limit of this sequence. And so how should I choose my value of epsilon so that the rest of my statement is actually a true statement? Well, one way to think of it is, let's suppose that I chose my epsilon to be fairly large. Let's suppose I chose it to be 1.5. Then is it true that there exists a capital N, there exists a point in the sequence, maybe it's right here, I don't know, such that everything in the tail of the sequence after that point, such that everything in that tail is not a part of this, sorry, let me try that one more time, such that not everything in the tail of the sequence belongs to that strip. If I choose epsilon to be 1.5, am I able to make that conclusion? That there's something not in that strip? No. I mean, if I choose epsilon to be 1.5, then what I'm really doing is I'm looking at the interval from negative 1.5 to 1.5 and asking, can I always find, no matter how far out in the sequence I go, a term past that point which is outside of the strip? And the answer to that is no. In fact, the entire tail of the sequence, in fact, the entire sequence itself belongs to this strip. So choosing epsilon to be 1.5 is not going to get us to where we want to be. So what's a better choice? If I choose any epsilon, which is less than 1, and here's an opportunity for you as the author of this proof to be very specific. Right? You don't have to just say, let's let epsilon be any number less than 1. That's not helpful to the reader. If we really want to drive this point home, let's be real specific. Let's say, let's choose epsilon equal to 1/2. If I choose epsilon equal to 1/2, then the argument that I need to make is that no matter how far out we look in this sequence, so here's my capital Nth term of the sequence, in this case it would be n equals 10, no matter how far out in the sequence we look, can we find a term of the sequence in this tail which is outside of the strip? We absolutely can. What's an example of one of those terms? Yeah, this term right here, which would be the 12th term, right? So there exists an n, in this case that n would be equal to 12, which is greater than or equal to 10, for which the absolute value of Sn minus 0 is greater than 1/2, greater than or equal to 1/2. Why? Because for that term, the value of that term is equal to 1, and 1 is greater than 1/2. Right? So this is the intuition, and this is why I recommend that you be very specific in how you choose your epsilon to really bring home the point to the reader that the rest of this will be satisfied. You as the author, because this existential claim comes at the beginning of the proof, this is when you can be super concrete and specific. Let epsilon equal 1/2. Now, let capital N be arbitrarily chosen. We're going to show that there exists a little n greater than that capital N such that the rest of this thing is true.